And in this example, we have vitamin C, which is ascorbic acid, and this compound contains only carbon, hydrogen, and oxygen. And it is given that so much of ascorbic acid gave so much of carbon dioxide and so much of water vapor upon complete combustion. And we are asked to find out its empirical formula. So the twist in this question is we are not given the percentage composition of ascorbic acid. See, in all the previous examples, in the question, we are directly given the percentage by mass of each of the element present in that compound. That made our lives easier. But here, that is not the case. Here, you have to first calculate the percentages of each of these elements present in this compound. How do you do that? First, you need to understand that whenever an organic compound is burned in excess of oxygen, also known as complete combustion, then all the carbon present in that compound gets converted into carbon dioxide, and all the hydrogen present in that compound gets converted into water vapor. You must have this knowledge to be able to solve this problem. So that means whatever carbon is present in 6.96 milligrams of carbon dioxide has all come from 4.64 milligrams of ascorbic acid. That means the amount of carbon present in 6.96 milligrams of carbon dioxide is equal to the amount of carbon present in 4.64 milligrams of ascorbic acid. Similarly, all the hydrogen present in 1.90 milligrams of water vapor has all come from this much of ascorbic acid. So, the mass of hydrogen present in 1.90 milligrams of water vapor must be equal to the mass of hydrogen originally present in 4.64 milligrams of ascorbic acid. So that is how you have to first calculate the masses of carbon and hydrogen present in this much of ascorbic acid. How do you do that? You know the molecular formula of carbon dioxide, it is CO2. And the molecular weight of carbon dioxide is 12 plus 2 times 16 approximately, so that is 44. So the molar mass of carbon dioxide is 44 grams per mole. And if you take 1 mole of carbon dioxide molecules, then the mass of 1 mole of carbon dioxide molecules would be 44 grams per mole times 1 mole, that would be 44 grams. So let us take 1 mole of carbon dioxide, that is 44 grams of carbon dioxide, and you know in that there is 12 grams of carbon. 1 mole of carbon atoms, and the mass of 1 mole of carbon atoms is 12 grams. Then how much carbon is present in 6.96 milligrams of carbon dioxide? First you have to convert milligrams into grams. To do that, you have to multiply this number with 10 to the power of minus 3. 1 milli is equal to 10 to the power of minus 3. Then you know how to solve this. The amount of carbon in this much of carbon dioxide would be this multiplied with this divided by this. And upon simplification, you would get the answer to be 1.9 into 10 to the power of minus 3 grams or 1.9 milligrams. This is the mass of carbon in 6.96 milligrams of carbon dioxide. But remember, all this carbon has come from 4.64 milligrams of ascorbic acid. Now, how do you find out the percentage of carbon? Simple. If 4.64 milligrams of ascorbic acid has 1.9 milligrams of carbon, then 100 grams of ascorbic acid will have how much? Again, you know how to solve this. Multiply these two and divide that product with this. So upon simplification, you will get it to be 40.9 grams, or its percentage is 40.9. And you do the same with the amount of water vapor produced. See, the molar mass of water molecules is 18 approximately. That is 2 times 1 plus 16 gram per mole. Then the mass of 1 mole of water molecules would be this multiplied by 1 mole, that would be 18 grams. And in 18 grams of water vapor, there is 2 grams of hydrogen, because in 1 mole of water molecules, there are 2 moles of hydrogen atoms. So 2 into 1 gram per mole. 2 mole into 1 gram per mole, so that becomes 2 grams. Then how much water vapor did we get here? 1.90 milligrams. So how much hydrogen is present in this much of water vapor? Again, you know how to solve this. And upon simplification, you will get it to be 0.2 into 10 to the power of minus 3 grams. Again, all this hydrogen has come from 4.64 milligrams of ascorbic acid. So this much of ascorbic acid has this much of hydrogen. Then to know the percentage of hydrogen, you have to know how much of hydrogen is present in 100 grams of ascorbic acid. Again, you know how to solve this, and it comes to be 4.3 grams. So this is the mass of hydrogen in 100 grams of ascorbic acid. So the percentage becomes 4.3. And because it contains only 3 elements, and we already know the percentages of carbon and hydrogen, you can calculate the percentage of oxygen by subtracting these two percentages from 100, and the percentage of oxygen comes to be 54.8. So now you know the percentage composition of ascorbic acid, and once you know the percentage composition, you know what to do. So these are the number of moles you would get for these 3 elements in 100 grams of ascorbic acid. Here the common factor, the greatest common factor between them, I think, is approximately 1.1, and 3.4 over 1.1 is approximately 3. 4.3 over 1.1 is approximately 4, and again this is approximately 3 within the experimental error. Then the empirical formula of ascorbic acid becomes C3H4O3. Now if I say its molecular weight is approximately 176, can you find out its molecular formula? I leave that as an exercise for you. But in this example, we are not given the percentage compositions, but we are given the masses of carbon dioxide and water vapor produced when a given mass of the substance is completely burned in excess oxygen. So from this data, you first have to figure out the percentage composition of that compound, then follow the steps to determine the empirical formula.